over the hills and far from mine. She's waiting for love to be realized. I'll send her my heart.
So first we will look at the definition of orthogonal basis. What is an orthogonal basis? An orthogonal basis for a subspace W of R power of n is a basis of W that is an orthogonal set. There are two properties to determine whether a basis is an orthogonal basis, which are the first one will be linearly independent and the second one will be orthogonal.
For example 1, we have to determine whether V1, V2 and V3 is an orthogonal basis of R3. So first step, we have to let V1 equals to 4 to negative 2, V2 equals to 0 to 2, and V3 equals to 2, negative 2, 2. So first, we have to show V1, V2 and V3 are orthogonal. So we have to find the value of sum of vector product, which are V1 times V2 is equal to 0, V1 times V3 is equal to 0, and V2 times V3 equal to 0. So we have to find the value. So let's find the value when V1 times V2. V1 times V2 is equals to 4 times 0 plus 2 times 2 plus negative 2 times 2 is equals to 0 plus 4 plus negative 4, and we get the answer is equal to 0. Next, we have to find the value of V1 times V3. So we get 4 times 2 plus 2 times negative 2 plus negative 2 times 2, and we get the answer. So next, to determine whether V1, V2 and V3 are orthogonal basis, we have to show that V1, V2 and V3 are linearly independent. So first step, we have to find x, y, z. So we have to construct an equation matrices, which is x times V1 plus y times V2 plus z times V3 is equals to 0 vector. Then we have to construct an augmented matrix, so we get this. So we have to reduce these matrices into REF form. After we get the matrices in REF form, we have to find the value of x, y and z. So we get z equal to 0, x equal to 0, and y also equal to 0. Since x equal to 0, y equal to 0, and z equal to 0, then V1, V2 and V3 are linearly independent. Since V1, V2 and V3 are orthogonal set and linearly independent, then these matrices are orthogonal basis.
For the second step, we need to show that V1, V2 are linearly independent. First, we need to find x and y. We let x and y be a scalar, and we form an equation. X times V1, which is 2, 1, plus y times V2, which is negative 1, 2, equals to 0 vector. Then we form an augmented matrix. We reduce to REF. We let 2 be a leading entry, and we have to make sure the entry below the leading entry must equals to 0, and we get the REF form. Next, we need to find the scalar x and y. First, we find y, 5y equals to 0. Then we get y equals to 0. Then for the first row, 2x minus y, we substitute y to the equation and become 2x minus 0 equals to 0, and we get x equals to 0.
For example 3, the question asks us to determine whether V1, V2, V3 are an orthogonal basis of R3. And then we let V1 equal to 2, 1, negative 1, V2 equal to 0, 1, 1, V3 equal to 1, negative 1, 1. The first step is to show V1, V2, V3 are orthogonal such that V1 times V2 equal to 0, V1 times V3 equal to 0, and V2 times V3 equal to 0. Firstly, we have to multiply V1 with V2, which is 2, 1, negative 1 times 0, 1, 1. It will become 0 times 2 plus 1 times 1 plus negative 1 times 1, and the answer will become 0. Second, we have to multiply V1 with V3, which is 2, 1, negative 1 times 1, negative 1, 1. And then 2 times 1 plus 1 times negative 1